Oh, sorry. Can you hear me now? Okay. No? Okay. Now, can you hear me? Okay. Good then. Okay. Thank you. Okay. Today we're going to start our final lesson. Actually, final physics lesson. This is a final physics lesson. Then after that, within this month, today is 18, 19. Then within 2 to 3 days we can complete this lesson. Actually, this lesson, ET student already know this lesson. ET students, are you complete electronics in engineering technology, electronic parts and electricity and electronics completed the lesson? Deneth Karal. Now doing. Others, Shevon, complete. Shevon, is it complete in ET class? There is a lesson including conductors, semiconductors, superconductors, and PN junctions. Like this lesson I asked. And BST also there is a lesson electronics. Am I correct, Amar? That is a lesson electronic PN junctions, different types of transistors, no, diodes. Yes. Then everything. I think everyone, is it complete? Is it covered in BST? I asked. It's almost covered. Shevon, in your side, వాళ్ళ క్లాసులు కర్లా? Actually, in this our lesson, actually we doing only basic things, very basic things. But first part, actually today lesson is very basic part of not electronic, electrical. Okay, electricity. Okay, we're not going to discuss about complex circuits and their different forms. We're not going to discuss that. You can discuss in the engineering technology and VST. Okay, in our lesson we doing basic things for your these technological subjects. Okay, that means ETO VST lesson we doing we provide basic knowledge. Okay, that's only we doing. But recently started. Okay. But I think the SFT you already covered now, because we doing very basic things. I think it will now now if you're doing now the electronics and electrical, it will help to this basic knowledge will help to understand advanced thing in BST and ET. Okay, actually in this lesson we come to advanced part at the final part in Kirchhoff laws. Kirchhoff law calculation is very important. And resistance systems we doing in the middle part of the lesson, resistance systems. Other parts are very simple, basic things we discuss. Okay. Before go to lesson, I'll show you a small video.
The central nucleus. This is known as the Bohr model. However, modern science has shown us that this is a simplified representation. In reality, electrons exist in more of a cloud around the nucleus, their exact positions defined by probability.
Okay, you know, if we consider every type of conductors mean the electricity transfer media. They all are made with atoms. Atoms are made with proton, neutron, and electron. You already know. They are nucleus contained with proton and neutrons. Then proton positive charge, neutron neutral. Therefore, you already know the nucleus is positive charge. Around that energy levels, they are electrons. You know, due to this positive charge and negative charge, it has attract electrons. There is attraction to the nucleus, no, for protons. Okay, now tell me, when increase the energy level, energy levels වැඩි වෙද්දී, when increase the energy level, this attraction is increasing or decreasing? When increase the energy levels, this attraction is increasing or decreasing? In biomolecule lessons, we discuss these basic things in molecule. Okay, think this is a one electron. There is another electron here. Think this is A and think this is B. A and B. If we think this A and B, consider A and B, which one has higher attraction, A or B? Higher attraction? Yes, A has a higher attraction to the nucleus than B. B has very weak attraction because it is the length, the distance is very high. I got the point. Distance is very high. Okay, we doing very basic things in O-level things. Okay, we need the molecule, the electron attraction is very low. Therefore, when increase the number of energy level, electron levels, what happened? Their attraction is, the bond is decreasing. Bond weak now. Therefore, due to this low attraction to the nucleus, free electrons are formed. These free electrons are very important for form a electric current. Okay, I will explain how to form electric current, how it is flowing, everything we can discuss. Okay, before that, watch this basic video and try to get the basic knowledge required for the lesson. Okay, watch this and get some idea. I will explain everything after that.
Abilities. But for today's discussion, let's stick with the Bohr model. It's a bit more visually straightforward and serves our purpose here. Now, let's focus on this tiny particle, the electron. It's this electron, with its inherent charge,
Negative
that plays
charge.
a starring role in the phenomenon we call electricity. When these electrons move, they create what we experience as electric current.
Okay. That we called as potential, supply any potential. Okay, potential actually voltage. Voltage means a potential difference. If you think it is a conducting media, whatever conductor, whatever small wire part, if we apply minus and plus charge, the electrons always transfer to minus to positive, because electrons minus charge, therefore it is flowing to minus to positive, minus to positive. Then what is the electric current direction? Minus to positive or positive to minus? Electric current direction, then what is the electric current direction? Minus to positive or positive to minus? Electric current direction. Very good. Very good. Electrons. Amma, do you know? I'm testing your basic knowledge. Okay. If you don't know, we can start from the very basic level. If you already know, we can start from the middle. Amavi? Don't know. Positive to negative. Already. Okay, positive to negative. Okay, electrons move into negative to positive. The electric current is formed from opposite side to the electron moving direction. Okay, see.
Your current. So when we talk about electricity, what are we really referring to? It's essentially the movement of these electrons from one point to another. Certain materials, like metals, allow electrons to move more freely. Their atomic structure is such that they have what we can visualize as a sea of free-moving electrons. While metals are good conductors due to this sea, other materials like rubber resist the movement of electrons. These are called insulators. Each electron carries with it a tiny negative charge. Specifically, it's about minus 1.602 times 10 to the power of negative 19 coulombs. 19 coulombs.
See this value?
Each electron carries with it a tiny negative charge. Specifically, it's about minus.
Yeah, this much of electrons, this much of coulombs. Coulombs, I will explain what are the coulombs. Please keep in mind this
times 10 to the power of negative 19 coulombs. When you bring together around 6.242 quintillion of these electrons, their combined charge equals a coulomb. When these coulombs of charge move through materials, such as in the wiring of our homes and devices, we see effects like light bulbs illuminating. This movement of charges over time, that's electric current. If we were to break it down mathematically, current, represented as I, is the charge Q that flows, divided by the time t it takes. So, a current of 1 ampere means 1 coulomb of charge flows every second. Before we move on, there's a fascinating tidbit you should know. When we talk about the flow of electrons, they actually move from the negative terminal to the positive terminal.
That we called as electron current.
Historically, the conventional current was defined as moving from positive to negative. This was set before we understood electron flow. So in most diagrams and textbooks, you'll see current represented as flowing from positive to negative. But remember, electrons themselves move in the opposite direction. It's a quirk of history we still observe today. From charging our phones to powering entire cities, this flow of electrons, this current, is fundamental to the.
Okay, that enough. I think you all have basic knowledge, but I will explain in the this lesson we starting from very basic level, and we can go for advanced calculations. This lesson actually basic things not asking in this lesson in the exam, but advanced calculations, especially from Kirchhoff law and Ohm's law, always coming question in the exam. Therefore, this lesson is very important. Okay, let's start from begin. From the basic level. Okay, you can download this lesson part 1 note in the website. I have already uploaded. You can go with any method into the 3-month program and download. Yesterday recording and yesterday tutorial, everything is there. Okay. Okay, that's the basic things explained as in the video. Okay, that's any molecule. It is made with proton, neutron, and electrons within the nucleus. Proton and neutrons. Proton positive charge and neutron no any charge. Therefore, overall nucleus is positive charge. Due to this attraction, electrons are the electrons in energy levels. Their energy levels, you already know. The number of electrons and number of protons depend on the molecule type. If you read this, you can get the basic idea. The matter is made up of atoms. The nucleus of atom consists of positively charged and protons and neutrons and negative charge electrons more in energy levels or shells around the nucleus. Under normal condition, the number of electrons in an atom is equal to the number of protons, making the atom electrically neutral. Metallic conductors. Conductors, I will explain what are the conductors later. Conductors are made up of a large number of atoms bound together by metallic bonding. All the electrons in the atom are bonded to its nucleus by electrostatic force by attraction. This attraction, electron attract to its nucleus due to this charge difference, positive and negative charge difference. The magnitude of these forces, see the magnitude of these forces, that means attraction is decreased when go away from the nucleus, more away from the nucleus. That means this energy level increasing, it's go away from the nucleus, then this attraction is decreasing. Due to this attraction decrease, free electrons are formed. That is, electron is energy levels far away from the nucleus are weakly bonded to the nucleus, and electrons in those energy levels exert more repulsive forces. Because of these facts, under normal conditions, electrons in the final energy level, last energy levels, more away from the nucleus, energy levels, all atoms of a metal have space to atoms from freely. This is very important, freely. Since these electrons move randomly like gas molecule, and those electrons are called as free electrons. When increase the distance between nucleus with nucleus, the attraction is decreasing, therefore it is freely available. It is free. Okay, like it is given as like gas molecule, air molecules are freely moving in the atmosphere. Samely, these free electrons also freely moving as given in the figure. They are freely moving. See, they don't have any specific direction. In the if we consider any conductor, whatever matter, free electrons are, these free electrons are moving freely. These free electrons are negative charge electrons, free electrons moving freely in this conductor. Okay, they are freely available without any direction. They don't have any direction. It is moving randomly and okay, like this. No any specific directions. They are free electrons. No any attraction to the nucleus. Free electron, freely available new electrons. Understood? Freely available electrons. Freely available electrons. Okay, I have given here, they are the free electrons and atoms. Okay. Now, if I consider any conductor or whatever matter, think if you got copper rod, it has huge amount of free electrons. Copper is a good conducting material, electric conducting material. Normally in your home electricity wires, the material is copper. Its resistivity is very low and its conductivity is very high. The reason is it has more free electrons. Copper molecule has more free electrons. That's the reason. Okay, therefore, if we think small copper rod or copper wire, copper cable, it has more free electrons and they are freely available, freely vibrating randomly without any directions. Okay, without any direction, they are freely available, like gas molecule, like air molecule. Okay, but they are freely available, freely moving until have a potential difference. Potential difference means if I supply here, I will draw again this. Okay, if there are no any potential difference, if there are potential difference mean if there are no any voltage supply, they are freely available like this, freely randomly available. Okay, but if I provide same conductor, if I connect with whatever conductor like this, so not conductor, whatever battery. If I connect with battery, this side is positively charged and this side is negatively charged. Therefore, potential difference is coming in the two sides of the conducting rod. Potential difference is coming. Due to this potential difference, remember, due to this potential difference, this randomly vibrated, randomly moving electrons start to move into negative side to positive side direction. Negative to positive side direction. Okay, they have a whatever specific direction. Now they have a specific direction. Initially they are randomly moving.
தற்பொழுது நிலவும் வறட்சியான காலநிலை நீர் நுகர்வு அதிகரித்துள்ளது.
Okay, sorry. Okay, what I told, if there are no any potential difference, that means if there are no any voltage supply, the electrons are freely moving along this conductor, no any direction. They don't have any direction, randomly freely moving in different directions, and they are collide and changing directions and freely moving like air molecule. But if we apply potential difference, that means simply if I connect with battery, one side is charged with positively and other side is charge with negatively charged. Okay, now what happened to the electron? These randomly moving electrons get specific direction to move. Then they negative charge, there is a repellent, and positive charge, there is a attraction. Therefore, it's more into this direction. They start moving to this direction. Now don't have random movement. It start to move into this specific direction, negative to positive. Negative to positive. Negative to positive. Okay, like they start to move into a specifically into a one direction, mainly positive direction. Positive direction. Negative to positive direction. That we called as the electric current direction. This direction, this blue color direction, that we called as electron current direction. That is the electron current. Due to electron is moving. It is not a true current, but the electric current is formed into opposite direction. Electric current, this is the I that we called as I, electric current. Okay, electric current is formed to the opposite direction of electron current. I got the basic. I think you already know these things. Understood? Any doubt up to now? I rapidly explain. I think in your answers, I can understand you already know these things. Okay, any doubt? Dinesh, I got. That is the electron direction, electron current direction. That is the electric current direction. Electric current direction. Yes, you all know. Arshit, I got. Sandeep. Okay, now go to the next part. Now you already know the every conducting materials are made with molecule. In these molecules, if they have free electrons, that can move, that can transfer, that can make electric current, that can flow electric current, they are the conductors. How electric current is formed due to electrons transfer. Now you can see that is a potential difference. That's a potential difference. Positive and negative charge, these electrons start to move into Now, if there are no any potential energy, they are randomly moving, no any direction. If there are no any potential difference, no any battery is connected. If it is battery connected, it has potential difference. Therefore, due to this potential difference, it is moving to minus to positive, that we called as electron current. Electron current direction. Positive to negative current is formed. Therefore, always current direction is positive to negative. Positive side to negative. Remember that. That is very important for our future calculations and our Kirchhoff law and every calculations and Ohm's law and everywhere. This current direction is very important. Current is always form from positive side to negative. Positive potential direction to negative potential direction. Okay, that's the basic. Okay, they are actually basic terms, not complex things. The next one is drift velocity. Drift velocity. Okay, what is the meaning of the drift velocity? Do you know? The drift velocity means the, as mentioned above, the speed which free electrons are drifting. These free electrons are moving velocity that we call as a drift velocity. Okay, basic terms in electricity. These free electrons are moving speed. These electrons moving distance into this negative to positive, negative side to positive side. That velocity we called as a drift velocity. Drift velocity is that is electrons velocity. Electrons velocity, simply electrons velocity we called as drift velocity. Drift velocity. Okay, these terms you have to remember for future calculations. Okay, this lesson also same as fluid mechanism. It has some basic things, and finally all these basic things combined to a some calculation part. Okay, in this lesson we mainly discussing about Kirchhoff law. Kirchhoff law. Okay, okay, that's a simple experiment. I think you already know. Illustration, the relationship between electric current and charge. Electric current and charge. Okay, that's a simple experiment. I'll show you this experiment. Give me a second. another experiment. I can't find this one. That's also electric charge. Rabi. Okay, that's the charge that you already know. Okay, samely, yes. Samely, this experiment, after rubbing this rod, whatever plastic or we can use whatever rod, and one hand we need to place a LED bulb, like as given in the figure. Okay, then this electric charge go through this bulb, and if you do this in a dark room, in dark condition, we can see small light coming with this bulb. Okay, then we can decide this electric charge is mainly electric charge is important for electric current. The relationship between electric current and charge, they are very simple experiment. Okay. Okay, now according to the very simple things, according to electric conductivity, matters can be divided into three types: conductor, semiconductor, and insulators. Conductors, semiconductors, and insulators. Okay, conductors. Conductors mean usually they have high amount of free electrons. If you, as given in the tube, large number of free electrons greater than 10 to the power 15, 10 to the power 15 per cubic centimeter. Small cubic centimeter, that's mean small cube, 1 centimeter cube of this conductor, it has 10 to the power 15 of free electrons. Free electrons. Okay, more than 10 to the power 15 actually. More than 10, greater than 10 to the power 15. Okay, that's amount of, if have this amount of free electrons, that we called as conductors. Conductors. If they have free electrons. Okay, these free electrons, then they can transfer more electric current. That's the reason when we apply potential difference. As the temperature increase, okay, this is important that we discussing again in the middle part of the lesson. When increase the temperature, what happened to the conductors? Its conductivity increasing or decreasing? What do you think? When temperature increase of any conductor like copper is a good conductor. Copper, silver, they are good conductors. Aluminium, they are good conductors. When temperature increase, its conductivity increasing or decreasing? What do you think? Increasing or decreasing? Others? When temperature increase, conductors, good conductors, I'm asking, good conductors, the conductivity increasing or decreasing? Good. No, Amar. It is decreasing. I am asking copper like good conductors. Copper like good conductors. When increase the temperature, the electric current conductivity decreasing. Why? That we discussing with experiment, everything I am explaining in the middle part after these basic parts. When increase the temperature, again go to the basic electric current. Okay, when increase the temperature of this, now already it has potential different. If with potential different, if increase the temperature, what happened? These electrons take more thermal energy and its vibration increasing. With increased vibration, what happened? With vibration increase, what happened? They are random movements increasing. With random movement increasing, their collisions increasing. Due to that, their resistance is increasing. Therefore, when temperature increase, the vibration is increasing due to high thermal energy absorbed by electrons. Therefore, their vibration increase, their collision increase due to everything, their resistance increasing. Resistance due to high resistance, its conductivity is decreasing. Good conductors, when increase the temperature, the conductivity is decreasing. Remember. Okay, don't worry, we can discuss again after the temperature effects in the middle of the lesson. Okay, now I have given conductor such as copper. It has 10 to the power 23 with free electrons within 1 cubic centimeter. Within 1 cubic centimeter. You can imagine what this value, 10 to the power 23. That means 10 and 23 zeros. 23 zeros. Okay, that's much of free electrons should have if it is conductor. Conductor means it is transfer electric current in large amount, that can transfer large electric current. Okay, the reason is it has bulk of free electrons. Okay, I have given examples: silver, copper, gold, aluminium, iron, steel, mercury, brass, graphite, water. Water is conductor. Water conductor or not? I'm asking H2O. H2O, electric conductor or not? H2O. H2O, electric conductor or not? Good, Isuru. H2O, pure H2O, pure H2O. That means pure water, not electric conductors. They are insulators. They are insulated. Yes, poor conductors. Poor conductors. That means pure water, it don't have any, its free electrons very low. Pure water. But I have given here water. But if we think our drinking water or whatever natural source water, it is what it is conductor. They are good conductors because naturally available water is not pure H2O. It is a mixture of iron actually. Lot of ions, magnesium, potassium, calcium, different sodium and different iron mixture is the natural water. That's mean impure. Impure mean not wastewater. Wastewater also conductor. Normal water, normally available, not impure, pure water. Pure water, not electric conductors, but impure water. Impure water, electric conductors. Electric conductors, that means H2O combined with different charge ions. That is electric conductor. They are good conductors now, naturally available water. Okay. Then concrete, salt solution especially, and acid solution, they especially conductors. Okay, these semiconductors, do you know how many type of semiconductors? How many types of semiconductors? Yes, two. What are the two types? Semiconductors, two types. Okay, that's not our lesson. We only discussing about electricity. In engineering technology and biosystem technology, you're doing electronics. We're not going to discuss about tronic. Okay, we only discussing basic electricity. Yeah, good. Amavi, I think you know. In VST also, I think you're doing these things. Semiconductors, mainly two types. What are the types? Intrinsics and yes, extrinsics. Okay, intrinsics means pure semiconductors. That means uh, fourth periodic group, fourth periodic, no? Fourth periodic group molecules like germanium, silicon. They are pure semiconductors. Pure semiconductors. Then what is other type? Other type is mixed with other molecules. Then it is again two types: P semiconductors and N. P and N. P type semiconductors and N type semiconductors. P mean the fourth group molecules combined with which group? PP. Third group like aluminium. Like aluminium, no? Then N type mean pure semiconductor combined with fifth group elements. Am I correct? Yes. In our lesson, we're not doing that levels. Just I explained there are different semiconductors, then PN junctions, diode, transistors you doing in electronics. Okay, then the semiconductors mean they are medium level, average, usually between this much of some amount, medium amount of free electrons, that therefore that the electricity conductivity also limited. Conductivity also limited, that can transfer medium level of electric current. Medium level of electric current. In these semiconductors, when increase the temperature, semiconductors temperature increase, what happened? Conductivity increasing or decreasing? Semiconductor temperature increasing. Semiconductor, yes. Semiconductor temperature increase, conductivity is increasing. Why? What's the reason? The reason is due to vibration increase. Their molecule vibrations increasing, therefore number of free electrons increasing. Number of free electrons increasing when increase the temperature. When increase the temperature of semiconductors, its molecular kinetic energy is increasing. Kinetic energy means their vibrations increasing. With higher vibrations, the free number of free electrons is increasing. Normally in pure semiconductors, it has only 10 to the power 5 to 10 to the power 10 like amount of free electrons, but with temperature increase, we can increase up to 10 to the power 13 to 14 level. Okay, then we can increase the conductivity value and reduce the resistance of increase in temperature of semiconductors. Increases the temperature of semiconductors. Okay, silicon, germanium, that's fourth group elements. Copper oxide, gallium arsenide. Okay, they are example for semiconductors. Okay, final one, insulators. Insulators are very low amount of free electrons. They are not, insulators are insulated also, they have some amount of 10 to the up to 10 to the power 3 free electron, but this amount is not enough for transfer electric current. Okay, transfer electric current, that amount is not enough. Okay, if I increase the temperature of insulator, what happened? If I increase the temperature of insulator, the conductivity increasing or decreasing? Temperature increase or decreasing? Increasing or decreasing? What do you think? If I increase the temperature of insulator, like rubber like material, if I increase the temperature with potential difference, what happened to the conductivity? Increase or decrease? What happened? What happened? Think. What happened? What happened? No. Yes. If I increase the temperature of insulators, if I increase the temperature of insulators, for conductivity, it is not affect. There is no any change. By only temperature, we cannot change its conductivity. As example, if you have whatever thing you have uh, glass, you have glass part. If I provide voltage, potential difference, and if we heat it, if there are no any considerable difference to air uh, of this glass rod electric conductivity, okay, uh, the number of electrons does not change due to temperature increase. The number of electrons again cannot increase, because in insulators they are the electrons attraction is very high. You need to understand in this level, their electron attraction is very strong. Bonds, electrons and nucleus attraction is very high. Okay, therefore this bond is very strong. Therefore, if we increase the temperature, the vibration increase, but due to these strong bonds, that cannot be changed. They are, the number of electrons is in considerable level, it's not increasing. That can increase in very small level, but it is not enough for electricity transformation. Okay, understood? Then what are the examples? Glass, rubber, oil, fiberglass, dry wood, pure water, especially pure water means H2O, pure H2O, pure H2O are insulators. And bakelite, paper, air, pure air with some particles, it is, it can possible to transfer uh, electricity, but normally in the atmosphere it is not transfer. It's not transfer. Okay, they are the insulators. Insulators. Okay, I got up to now. We discussed the basic part up to now. Are you good? Okay. Okay, now we're going to discuss what actually this is the lesson we starting from this point. Lesson we starting from this point because the previous parts are basic, common, general knowledge. Okay, general knowledge. Okay, then we're going to start to discuss electric current, voltage, and resistance separately. Okay, the basic electricity concept. Okay, electric current, electric voltage, and electric resistance. Okay, then this part, theory part, is completed of this lesson. Okay, then you have Kirchhoff law, then the lesson is completed. Okay, very simple this lesson. Okay, then we have few calculations. Actually, the final part calculation, very important. We need to take more time for this final part calculation. Okay, today our target is complete all basic parts. Okay, complete all basic parts. Then next week mean our next day discussion of electricity. Then complete lesson is theory part we can complete. Okay, then actually we only need one more day for this lesson. Okay, it is not a complex lesson, won't have more theories, but you have to understand some calculations, more type of calculation in Kirchhoff law and resistance systems. We need to practice more calculations. Okay, electric current. Okay, the electric current, it is some definition, it has some definition. The rate of flow of electric charge through a cross section of conductor. The rate of, the word understand, the rate of flow electric charge, electron charge rate, that we called as a electric current. In otherwise, the amount of charge passed through a conductor within unit time. Within unit time, if we think a small conductor, this is very simple. Think it is a small conductor. Think this is a conductor. The amount of electron, the amount of charge mean electrons, the amount of charge mean Q, coulombs. The amount of Q passed through this conducting rod, whatever cross section of this conducting rod, within unit time, that we called as electric current. In other words, the rate of charge flowing through a cross section of conducting rod. The rate of flowing electric charge through a conducting rod, that we called as electric current. Okay, according to both equations, the amount of charge that has passed through a conductor within unit time, the unit time, very important, the amount of charge within unit time, then we can get a relationship. The current equal total free charge means free electrons, divided by the time. In short form, the I equal Q over T. The Q means the amount of total charge. Q, I have given here. See here. Then the Q unit is coulombs. Time unit is second. Then what is the unit of current? Then I equal Q over T, the amount of charge within unit time, the rate of charge pass into a conducting rod. Okay, the rate of charge pass into a conducting rod. That means In other words, the amount of charge passing through a conducting rod within unit time. Within unit time. Okay, then the charge unit is coulombs. Remember, coulombs is a charge unit, and the time unit is seconds. Time unit is seconds. Then we can get the unit of current. Current symbol is I. Remember, I is the current symbol. Then it is coulomb, and it is seconds. Then the unit is CS minus 1. Coulombs per second is the unit. Coulombs per second is the unit. But this 1 coulombs of 1 coulombs of second, 1 CS minus 1 equal to 1 ampere. I equal 1 CS minus 1 equal to 1 ampere. Ampere is actually samely, it is scientist name. The current concept found, scientist name is the ampere that we use as the standard unit for current. That we use as the standard unit for current. Okay, ampere. Ampere is the unit. Then how we define the current? The rate of charge flow through a conducting rod, or the amount of charge flow through a conducting rod within unit time. Okay, whatever method, you have to remember the equation. Whatever method, you have to remember the definition and equation both. Equation is, what is the equation? The amount of charge divided by the time. What is the definition? The rate of charge flow through a conducting rod, or the amount of charge flow through a conducting rod within unit time. Okay, remember both. Okay, both explaining same thing. Okay, that is the current. That's the current. I got. Okay. This is the, now you got first equation of the electricity lesson. Sorry, it is I equal Q over T. I equal Q over T. I equal Q over T. The number of charge divided by the time. Okay. We move into second one. The second one is density, current density. Okay. This is the symbol. Actually, it is not the J. Its symbol is like this. Like this. It is given. This is the correct one. Okay. The elastic, sorry. Okay. What is the current density? The current density, simple, the amount of current flowing through a unit cross section area. That's the meaning. The electric current flowing perpendicular to unit cross section area. Within unit cross section area, the amount of current is flowing. The same thing. The amount of current flowing through a unit cross section area. The amount of current flowing through a unit cross section area that we called as a current density. Current density. Current density. Okay, you can get the current density. Current density. Current density. Okay, current density equal the amount of current flowing through the conductor. The amount of current, it is given, not given in the tube, the amount of current flowing through a conductor divided by the cross section area. Cross section area. Okay, that is the simple equation of the current density. What is the definition of the current density? The amount of current flowing through a unit cross section area of the conductor. The amount of current flowing through a unit cross section area. The amount of current flowing through a unit cross section area that we called as the current density. Okay, now if you go the current density, this is current density, the amount of current mean I, the cross section area mean A. Okay, when increase the current amount of current, when increasing the current amount, what happened to the current density? When increase the current, that means current value, what happened to the current density? It is directly proportional, no? According to this equation, it is directly proportional. Then I think now you can understand current density directly proportional to the I. That's mean current density, current increasing, the current density is increasing. Current increasing, current density is increasing. Okay. Now, how about the current density and A? A increasing. What happened to the A increasing? Current density is decreasing. Good. That means it is indirect proportion, inversely proportional. It is inversely proportional. Okay, that's the relationship. Current and current density directly proportional. That means current increasing, the current density increasing same. When increase the cross section area, current density is decreasing. When decrease the cross section area, current density is increasing. Current density is increasing. Okay. 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 Now, why this current density is important? Can you imagine? Why it is important? That's a simple current density. Now you know current increasing, current density increasing, cross section area decreasing, current density increasing, directly and indirectly proportional. Why we need this current density? What is the importance of this current density? Can you imagine? Why it is important? Why it is important? What's the reason? Why it is important current density? In industrially and in practically, what is the purpose? Why we calculating this current density? To select wire. Very good, Adish. Others? Isuru, what is the advantage and what's the purpose of actual this current density calculation? Why we doing calculate the current density? What's the purpose? Idea? Amar, why we calculate? What is the importance of this current density? Yes, not the concentration, density of the current flow. It's not the concentration, density. Okay, good. Then it this current density actually we need for select conductors. Select conductors. Okay, think what is the unit of this current density? Current density unit is ampere. The current unit is ampere. It is square meter. AM minus 2. AM minus 2 is the SI unit. SI unit. Amperes per square meter. Amperes per square meter. Okay, why it is important? What's the important to select suitable conductors, select suitable wires. Okay, if you observe your home wiring system, where it has more thick wire, කොහෙද higher diameter wire එක තියෙන්නේ? Where? High diameter wire, where it is located? Now in your home wiring system, from very good, Adish. Very good. The ලොකුම diameter එකක් තියෙන wire එක තියෙන්නේ කොහෙද? ඉසුරු high cross section area තියෙන wire එක තියෙන්නේ. You know, in your rooms and whatever your switch, light switch, it's coming very small wires, small cross section wires, small cross section wires. If you now you know the main supply wire directly connect to the meter board. It supply to the meter board. Then from meter board to distribution, tip switch එහෙම තියෙන tip switch that we called as distributor box, that is the most thick wire. Why they are science, physics. Why it has more thickness, it has more cross section area? What's the reason? It's coming more current. The current increasing. Think the I over A. It is the current is high. The current flowing amount is very high, very large amount of. Very good. Okay, the amount of current is very bulk current is coming directly supply meter board to distributor box. Okay, then it is the current amount is bulk. Therefore, how about the current density? The current density is also high. Current density also increasing. Therefore, to reduce this current density, we have to improve the cross section area. We have to increase the cross section area. Then we can reduce this current density. Otherwise, more than tolerant level, if it is increase the current density, what happened to this conductor? Now I ask, if I apply very small, same as your switchboard, in small conductor, small thickness conductor, thin conductor, if I apply to this line, what happen? Again, choti wire එකක් දැම්මොත් what happened? What happened? Yes, burning. When increase the current density, first of all, it is the temperature increasing. Temperature increasing, it is heat up the conductor. After some time, it is burning and melted. It is melted due to high temperature. Okay, therefore, in you use in your day-to-day life also, if you in your whatever switch, if you plug more, if you get more electricity in one plug, it is dangerous. It's dangerous to plug. Okay, it has very small thickness cross section area conductors. Therefore, if you try to get more electric current, its current density is increasing, that therefore they can burn. Okay, if you need to get out more electric current, now you can understand, more electric current transfer, you need to use high cross section area conductors to reduce the electric density. Understood the usage of electric density? Amavi, I got Tenet. Therefore, if you transfer more electric current, always we need to use the thick conductors with high cross section area. Cross section area increasing, that we can decrease the density, current density. Okay, if you want, you can note down this short note, because it is not given in the note. Okay, make a short note of this lesson and attach, if you can, take a printout of this lesson note. Okay, this lesson note very small, only 10 to 12 pages. Okay, don't need to send printed tudes. You can take a printout and print out and attach all this, make a short note and attach this with all calculation attached to this tube, print out, then you have electricity tube. in current density, you need to keep in mind when increase the current density is increasing, and when increase the cross section area, the current density is decreasing. Therefore, if you flowing more current through the conductor, you need to select more cross section area conductor. More cross section area conductor with more cross section area. Okay. Okay, I have given full note here. In physics, electric current is not considered as vector. Current density is a vector. Current density has a direction. Okay, current direction same, but in current we not consider as a vector. That's a special thing. Current also, but the current also has a specific direction, but we not consider as vector. That's a special case. But current density is a vector. Current density is a vector. Current density varies with some different surface areas. You know, A1 and A2. A1 and A2. A1 has large cross section area and it is small cross section area. Now I have given the current density is inversely proportional with the cross section area. Then this side current density. Think same current is through this flowing through this conductor. Then what happened? It is same as continuous flow. Continuity equation in fluid mechanism same. Then what happened? This surface, this side, one side current density is low. So what happened? Oh, sorry. One side current density is low. See, current density low, and A2 side due to low cross section area, its current density is huge current density. Current density is increasing. Current density is decreasing due to low cross section area. It is given here. Right? Rho 2, current density 2. This side it is increasing due to low cross section area. Okay, that's very important. Okay, when we select conductors for whatever purpose, according to the amount of current flow in this tube or whatever conductor, we have to select suitable conductors with proper cross section area. Cross section area very important, the diameter very important. Okay, the diameter important. Otherwise, when we plug into get current, it is burning after small time. After a small time, it is burning. Okay, therefore that is important. When current flow through a conductor of different cross sections, the current density will be changed accordingly. As the cross sectional area decrease, the current density decreasing. Okay, same. That's a relationship. This type relationship graph always coming in this lesson. Always asking this type relation type graphs. Okay, the variation of current density as cross sectional area change. It is, you can see, when increase the cross section area, the current density is decreasing into like this. Okay, it is not actually, it is, if it is inversely proportional, it's not decrease like this. It is decreasing in a curve way, like this. Curve way. This is a graph. It is decreasing in this shape, with this shape. Remember this. Okay. In this lesson, lot of graphs you can meet in the future parts also. You have a lot of graphs. Okay, you have to remember these graphs. Okay, these graphs you can remember with calculations. Our calculations you can keep in mind. But this is a special case. Now you know the current density and cross section area is inverse proportional. It has inverse proportionality. Inversely proportional. Therefore, when increase the cross section area, the current density decreasing. It is not decreasing in linear way. It is decreasing as a curve like this. Remember, as a curve. As a curve. Okay. The electric current flowing through a closed closed circuit is measured by ammeter. Yes, ammeter. It is need to connect with series. You already know in all level time also. It need to connect serious way into a closed circuit. Okay, that's all about electric current. I think now you have a full knowledge about electric current. What's the electric current is forming, what are the electric current directions, what is the electric current density, and what is the equation of electric current, how we get the unit, what are the standard unit, what are the equations, and what is the current density, and what is the usage of this current density. Any doubt, please you can ask. Any doubt, please you can ask. Do you have any doubt up to now? Any doubt up to now? All clear? The current complete. Any doubt, please ask. Others? No doubt. Okay, great. Amar, Arshad, clear up to now? Okay, this lesson calculation part we can discuss after this theory part. Actually, one by one calculation don't need for this lesson. I think they are very simple things we discussing. You already know. In even 24 class, we only did calculations of this lesson. We not covered this basic theory part. We only did Kirchhoff law and Ohm's law calculations only, because we cannot arrange time for this one. Therefore, with our time, we only did calculation of this part. But this time we have enough time. We have more 2 months. Therefore, we can complete within very short time and we can discuss calculation. Okay, voltage. Voltage, how we define the voltage? Actually, the voltage is the potential difference of the potential difference between two sides of the edge of two edge of any conducting rod, any conductor. The potential difference, that is the voltage. When a conductor is connected to a source of electromotive force at both ends, an electric field is created with this conductor. The resulting electric field causes a high potential at one end and it has higher electron pressure. It has higher electron pressure. That means plus side. Plus. This is plus. Higher electric pressure. Across the two ends of a conductor is called as potential difference. Other end has low potential uh, energy. Potential energy. That's mean other minus side has less electron pressure. That difference we called as a potential difference. This potential difference is the voltage. Its unit is volt. The potential difference is the voltage. The potential difference is called as the voltage of any conductor. Okay, that's the voltage. The standard unit is volt. It is volt, and the potential difference closed circuit measured by voltmeter. I have given the voltmeter, and the voltmeter connected to a closed circuit with how we connect parallel, not series. We need to connect with parallel. Okay, as I given, we need to connect parallel. Okay, that's the voltage. We discussed about voltage in the Kirchhoff laws. Therefore, only we doing basic things. Okay, now voltage and electric current is completed. Now we're going to discuss about Ohm's law. Okay, actually, this is the most important part of this lesson. This one and Ohm's law, sorry, Kirchhoff laws are the very important part. Okay, give me a second. Okay, the Ohm's law. Ohm's law. Okay, Ohm's law, I will explain this Ohm's law with simple experiment. Okay, this Ohm's law is actually simple concept that found by a scientist, the name as Ohm. It is simple experiment. Okay. Okay, now think about this experiment. Don't think any concept, what is the meaning definition of Ohm's law. Don't take. If you understand this concept, you can understand everything in the Ohm's law. Okay, now think this is electric conductor. This is electric conductor, electric wire. Okay, now think this I connect with a battery, connect with battery, and we connect ammeter here. Ammeter we can connect series, and again I connect voltmeter for this battery. Voltmeter for this battery. It should be parallel. It should be parallel. Okay, now I'm going to measure. Now very simple. Now I'm going to measure no need 3 column, 2 enough. Okay, now this is the voltage and this is the ampere. This is the voltage and current from ampere. Ampere is the unit. Okay, now I'm going to change the volume. I'm going to change the volume and measure the current. Okay, now sorry, I'm going to change the voltage and measure the ampere value, current. Okay, now in the first attempt, in the first time, think the voltage is we starting from 2 volt. The ampere, the amount of current flowing through this conductor, think it is 1 ampere. Example, okay, 1 ampere. Okay, think if I increase to it is 4 volt. The voltage increase up to 4 volt. It is the current increase up to 2 ampere. If I increase the voltage up to 6 volt, the current increase up to 6 ampere. If I increase the voltage up to 8 volt, the current come to 4 ampere. 4 ampere. Okay, that is the Ohm's law. That's Ohm's law. If I consider the relationship between these two, current and voltage. Okay, now you should careful this time. This type experiment, what we changing, voltage or current? Now tell me, voltage or current we changing? Variable factor, or that we called as independent factor? What is dependent? What we changing here? Voltage or current? I need answers. This one we changing voltage or current? Yes, it is changing voltage. Then voltage x-axis or y-axis on this graph? On this Cartesian plane, voltage need to others? Amar, what do you think? Yes, we changing. Voltage is the changing factor that we changing. And check the ampere, check the current. Voltage is the changing factor. Then which axis we add voltage on this graph? X or Y? What do you think? X or Y? Good, Isru. Others? Amar, Arshad? X-axis or Y-axis? Sandeep? X or Y? X or Y? Don't think this one. I'm asking our experiment. Our experiment? Yeah, this one Y, okay. But in our experiment, we changing X. We changing voltage. Therefore, it should be come to X-axis. That depend on the experiment type. Okay. Then if we change in the current and measure the voltage, then it's okay. Then it is different. Then it should come to voltage here and the I into y-axis. And you just need to mark these values. Voltage 2, 4, 6, 8. 1, 2, 3, 4. Okay, if you mark these values, you can see it is coming a straight line. It is coming a straight line. The result is a straight line go through a origin of the Cartesian plane. It is a straight line coming, go origin with the Cartesian plane. Okay, that is the, now it is a straight line go through the origin mean what is the relationship? It is inverse proportional or directly proportional relationship? Direct relationship or inverse relationship? What do you think? Direct or inverse? Direct or inverse? What do you think? Directly proportional or inversely proportional? This is the graph shape. Direct or inverse? Yes. Others? Directly proportional or inverse proportional? Directly or inverse proportion? Yes. No, Yasindu. Inverse proportional. This relationship is very important. Think there is a graph. What is the meaning of directly proportional? Directly proportional mean x-axis component increasing, y-axis also increasing. Think, Palan. Increasing, this one increasing, increasing. That is the directly proportional. This is the directly proportional. Inversely proportional mean like this. They are basic things. Inversely proportional mean like this. Same as previous graph, current density and cross-section area. Do you remember current density and cross-section area? The graph was like this. Graph was like this. Inversely proportional. Think now you can see, if we can consider about this line. This line. Okay. Increasing, the y value is decreasing. This is the inversely proportion. This is the inversely proportion. If it is coming this type line, it is directly proportional. Directly proportional. Directly proportional. Directly proportional. Okay, this I and V changing, don't think about. Okay, it is depend on the experiment. It is depend on the experiment. Always you experiment the changing factor. You changing factor. Api venas karana එක. The variable factor always you need to put into x-axis. Always put into x-axis. Okay, that's a rule. Okay, in mechanical properties also same. Every questions, every practicals, tomorrow we can discuss. Tomorrow compulsory practical session, compulsory for all. Tomorrow we discussing parallelogram theorem and moment of forces practical. It is compulsory. Otherwise, in a structured paper, you will have lot of troubles, lot of issues if you don't know these basic things. These basic things actually this how to make a graph and what are the how we get a relationship with graph. Everything we discussed in the practical class. Therefore, don't miss anyone this practical class. Okay, tomorrow practical is very important. That is not given in our lesson. Moment of force lesson or force lesson not given this parallelogram theorem and moment of force practicals. Tomorrow we discuss fully with all practical sessions, all practical requirements and graphs, everything we doing, parallelogram theorem and moment of forces. Okay, now you can see. Now I think you got the practical Ohm's law. Then I measure the changing voltage. I measured the current flowing through this circuit conductor. Then I can get idea. It is a straight line going through the origin of the Cartesian plane. Then I understood. I can identify. It has a directly proportional between this I and between this V. I and V mean voltage and I. Voltage and I. Voltage and I. Voltage and current. Okay. Therefore, understand the Ohm's law. How we define the Ohm's law. Temperature and other all physical factors, if constant, keep constant, remain constant, the current flowing through any conductor directly proportional. That's the Ohm's law. Current flowing through any conductor directly proportional to the potential difference of the conductor. Potential difference means V. That is the Ohm's law. That's Ohm's law. You can read now. You can read very simple concept. He has explained a very simple concept. When the temperature and other all physical characteristic of conductor remain constant, this is compulsory for Ohm's law. Temperature and other all physical characteristics remain constant. The continuous electric flowing through the conductor is the continuous electric current. Continuous, don't think I will explain again later. Electric current flowing through this conductor is directly proportional to the potential difference across it. Potential difference between two sides. Okay, that is the Ohm's law. Temperature and other all physical characteristic of conductor remain constant. They are constant. Okay, temperature should be constant. Both end temperature should be constant, and other all, if there are no any factor effect on this object, effect on this conductor. That's the meaning of the first line. When temperature and other all physical characteristic of conductor remain constant, the electric current flowing through the conductor is directly proportional to the potential difference across it. There is a mistake. It should be I. Should be I. Mistake. It's I. It's I. Okay, I got the Ohm's law. Then if anyone asks, define the Ohm's law, you have to explain when temperature and other all physical characteristic of conductor remain constant, the continuous electric field, continuous electric current flowing through this conductor is directly proportional to its potential difference. Can you explain? The basic thing only you need to remember, V directly proportional to I. The graph like this. V and I, the graph like this. Understood? Understood? Okay, don't take anything now. They are very simple things now. Don't take anything to remember later. Now you can remember everything. How we explain the Ohm's law? Read with me. When temperature and other all physical characteristic remain constant, the continuous electric flow through this conductor is directly proportional to the potential difference of it. Yeah, the basic thing, the voltage, the potential difference. Voltage means potential difference. The voltage directly proportional to the current. That's the basic thing. Okay, this is a basic thing that you can explain like this. That's Ohm's law. Okay. Everyone, can you remember this? This is the Ohm's law. Simple. Don't keep anything to remember later. Please try to understand and keep remember within the class. Okay, any doubt up to now in Ohm's law? I explained the basic meaning of the Ohm's law. Basic meaning of the Ohm's law. Temperature and other all physical characteristic of a conductor remain constant. The continuous electric current flowing through any conductor directly proportional to the potential difference of it. Great. Complete. Good. Okay. Again, we can explain the Ohm's law again. The ratio between this potential difference and the electric current, it is a constant. It is a constant. V over I, it is a constant. That's another form we can explain the Ohm's law. Ohm's law. Okay, that's a constant. Okay, I will explain that again. The Ohm's law is if temperature and other all physical characteristic of any conductor remains constant, the amount of continuous electric current flowing through this conductor directly proportional to the potential difference of it. Okay, that is the Ohm's law. The Ohm's law, V directly proportional to the I, that's a basic concept. Samely, we can say the V over I, that's mean the ratio between I, it is a constant. Okay, I will explain. You can get the what is the meaning of this constant after this discussion. Okay, now according to our explanation, V directly proportional to the I. Okay, I need to make a equation from this relationship now. What we can do? How we make an equation? I need to remove this proportional mark. How I remove this proportional mark? This proportional mark we can remove. We can remove the proportional mark. V equal to I. V equal to I. In physics, if I convert proportional mark into equal, what we need to add? Everywhere in physics, proportional mark convert into equal, what we need to add? What we need to add? Guys, please send answers. Please send answers, then it is easy for me to continue. Very good. We need to add whatever constant. We need to add whatever constant. Then this constant I adding in this equation, the constant is R. Constant is R. Then V equal IR, the common equation coming. This is the common equation coming according to Ohm's law. According to Ohm's law. According to Ohm's law. Okay, if it is equation, the equation is that. Now you can understand. Now if I isolate this R, if I isolate this R, what is the value? If I isolate this R, it is V over I. V over I. I think now you can get idea what is explaining here. V over I is a constant. This constant is the R. This constant R we called as the resistance of the conductor. Understood? This R we called as the resistor of the conductor. Resistance. That is the resistance. That is the resistance of the conductor rod. Are you got? The resistance is the factor depend on the matter type. It is a constant depend on the matter type. Same as previous question relationships. Understood? Listen me. Understood? Very simple thing I got. According to Ohm's law, V directly proportional to I. Then I remove this proportional mark by adding equal mark. Then V equal Ri coming. Then the same equation I converted into V equal IR. V equal IR. V equal IR. Then R equal V over I. This is a constant. This is a constant. This is a constant depend on the material type. The R we called as the constant, that is R. The R we called as yeah, variable resistors, that's different, like a switch, normally that we changing, manually changing. Normally the resistance is a factor that depend on the material type. As example, if we consider about the resistance of copper and aluminium both are good conductors. Which one has higher resistance? Copper and aluminium. Which one has higher resistance? What do you think? Basic knowledge. මොන වගේද වැඩි resistance එකක් තියෙන්නේ, මොන වගේද අඩු? Good. Aluminium has higher resistance than copper. But you know, for the electricity transformation, these wires in roads, electricity transfer mainly by copper wire or aluminium wire. පාරවල් වල තියෙන copper or aluminium wire. Aluminium. Then why? Why? If it is copper has low resistance, why without using copper we use aluminium for this transformation? Yes, the reason is others. What is the reason? Copper has low resistance, then most suitable one is copper actually, but we use aluminium. Yes, that's the reason. Copper is the most applicable one, but copper price is more expensive. Aluminium cheaper than copper, many times cheaper. Copper price is very high. That's why if it is has higher resistance, not too high, it is comparatively high. Okay, comparatively high. If it is higher resistance, we use aluminium for electricity transformation in electricity board. Okay, Amar, same. The copper, if we consider copper wire, it has a specific R value. It is a constant, depend on the material type, copper. If we consider aluminium, it has more than that resistant value. Understood? That's depend on the matter type. Aluminium has a specific resistance value. Copper has another specific resistance value. If we consider silver like, it is another resistance value. If you go to what else, sodium like metal, it has another resistance value. Understood? It's depend on the matter type. Depend on the matter type. Okay, very good questions. Okay, any other question up to now? Okay, what we discussed, very simple thing we discussed, according to Ohm's law, V directly proportional to the I. That means voltage potential difference directly proportional to the current. Then to remove this proportional mark, I use equal mark and add constant for the proportional mark. Then this constant is the constant is the R. The constant is the R is the resistance that depend on the matter type. Okay, I think you got the note I have given here. Everything is explained here. According to the above equation, when increase the value of this constant, decrease the electric current. Yeah, that's also important. I will explain that. Given potential difference. This is because the constant mentioned in this equation is inversely proportional to the current. Yes. If this is the equation V equal IR equation. If I isolate the R, V over I. When increase the resistance, you already know this. When increase this constant, that means R increase, resistance increase. This is the electric energy transformation ability. Electric transfer ability is decreasing. That you already know. The resistance mean actually it is the actual resistance. No any word. This constant is called as electric resistance, and symbol is capital R. Symbol is capital R. Then you already know this equation V equal I R. V equal IR equation coming with Ohm's law. Ohm's law. Remember this relationship. Okay, now very, very important point. Okay, now we have equation according to our relationship. We have equation V equal IR. According to this relationship, we have equation V equal IR. V equal IR. Okay, if you want, I'll write again. V directly proportional to the I. Therefore, V equal IR equation. We have, this is our equation. Now, in previous experiment, we got a relationship between V and I, correct? V and I, we got a relationship like this. Relationship. Okay, then the relationship was like this, directly proportional. No? It is a straight line go through the origin. Okay, now if you want, I can add values here. Voltage, I added 2 by 2, 2, 4, 6, 8. 1, 2, 3, 4, correct? Yes. Okay, now this is the graph I got from the experiment. This is the relationship V equal IR. Now this, if I consider this is okay, what is the common equation of this graph? It is Y equal mx. No any intercept. The intercept is 0. That's the most important part of the practical and the lesson. Okay, everything you already know. This is a point you need to understand. Focus very well for this part. Others you can understand. Okay, V equal IR, you already know. If I explain many times, you already know this. I know. In O level time also, you know. But this point important. Y equal mx. Y equal mx. Now, my in this equation, the y value is y is I. Y is I equal. That's the purpose. We have to change this site. Okay, to get this relationship. That's why in the tude given in the opposite way. That's why tude given in opposite way. We have to get the y-axis into V voltage. I will draw it again to get this relationship. Now I am going to draw this same graph by changing the V and I. I get into this side. 1, 2, 3, 4. The voltage change 2 by 2, 2, 4, 6, 8. Then a graph, if graph is like, okay, now according to this graph, if I draw any direction, it is a same graph is coming. Okay, it is directly proportional. If increase the I, voltage increase, I increase. Okay, both same. Okay, now think this graph, the y-axis is V. Y-axis is V. And the gradient, keep later, the x-axis is I. X-axis is I. The gradient is capital R, remember. V equal Ri. V equal Ri according to this graph. Then you can see the R is the resistance is the gradient of this graph. The resistance is the gradient of this graph. Then if I can find the gradient of this graph, then we can find the resistance of this conductor. Think it is AB conductor. AB conductor resistance we can calculate by the gradient of this graph. Gradient of this graph. Actually, we can calculate the actual value. The gradient equals, think this point is x value is 4, y value is 8. This point is 0, 0. Then I know two points, then we can get the gradient according to Cartesian coordinate geometry, y2 minus y1 over x2 minus x1. This is a gradient equation. Now I can get the gradient for this x graph, y2 minus y1, 8. 8 minus 0, x2 minus x1, 4. The gradient is 2. Then the resistance is 2 ampere. 2 ohms. 2 ohms are the resistance. Understood? This type practicals always coming in structured and essay questions in this lesson. Get the full idea what I explaining here. Are you good? Or do I need to explain again? Do I need to explain again? Yes, let's discuss again. Okay. Now don't think about these I and V directions. It is directly proportional. No? It is a straight line coming. If you draw this graph in both direction, it's coming a straight line. Straight line. If I change this, don't think. Okay. Now come to the point. Okay. According to Ohm's law, what is the relationship? V is directly proportional to the current. Okay. V is directly proportional to the current. Then according to this, that we can get V equal IR. Then in the experiment, you know, it is coming a straight line going through the origin, then 0, 0 point. Okay, you already know if it is straight line going with origin, no any intercept. Intercept is 0. Intercept in y-axis cutting point. Intercept is 0. Then y equal mx is the equation of this graph. Y equal mx is the equation of this graph. Then this is the graph. This is the common equation. This is the graph. This is a common equation. Now this graph, the x-axis I got I. This is the I. This is the x value I. Y-axis I got V. Then according to this equation, V equal IR, the gradient y equal mx, the m gradient should be resistance, R constant. Then using this experiment given graph, if I found the gradient, this gradient value is what? Resistance. We can do more exam questions. This gradient value is the, this is a constant depend on the matter type. It is the resistance. Okay, that you need to remember. If you draw graph between this current and voltage, its gradient always given the, its gradient, this graph gradient is always given the resistance. It is the constant that depend on the matter type. Have you got? That's the basic thing you need to remember. Experiment graph given gradient, it is the resistance. That's a constant. Understood? Amar, Arshat, Timira? Simply මේ equation එක අපි y equal mx විදියට හදාගන්න. Okay, after make as y equal mx type, then its gradient of this equation, make a gradient එක equal වෙනවා make a resistance එක. The y axis V, x axis I, the R is the gradient. If you found the gradient of this, if you found the gradient, now you know the gradient we already discussed in the coordinate geometry. The gradient means the tan angle or the slope of the slope into the positive side x direction. Positive side x direction. The slope into the positive side x direction. If you found the gradient, this gradient calculation method we discussed in not in this lesson. It is coordinate geometry. If you whatever method, if you found the gradient of this graph, it is the resistance of the conductor. Any doubt? Please send me. Any doubt? Please ask quickly. This is the most important part of this lesson. Other part simple. I got. Please send me. I got, or do I need to explain again? Or quickly. Amar. Timira? Okay. Yeah, that I have given. Y equal mx, v equal ri. Then m is equal to r. M is equal to r. M is equal to r. This is when I is plotted against V. It is, I mean, current, okay? I is plotted against V as above. The resistance can be obtained by the gradient of the resulting straight line. Resulting straight line gradients given the resistance of the conductor. Resistance of the conductor. Resistance of the conductor. Okay, then I have given about resistance. The resistance, the opposition to flow electric current, that is the opposition force. The opposition force due to electric for flowing direct electric current, that we called as the resistance. That we called as a resistance. The standard unit ohm. Ohm. This is a symbol. Ohm. Ohm. Like a cap. Like a cap. Okay. Okay. Now in molecular level, how it is forming? How it is the resistance is forming? How it is forming? Okay. When how it is resistance forming? Now think it is a molecular conducting rod. They are free electrons. Free electrons. Okay, do you have any idea how it is resistance is formed? Resistance එක කොහොමද form? The opposite force. Now if I given any potential difference, battery set කරා. Think this side is positive and this side is negative. Electrons start to move into this direction. Electrons start to move into this direction. Then the current is flowing to plus to negative. Current is flowing to plus to negative. Then how this resistance is formed? Any idea? I need answer from now. I explain everything. Now you have basic knowledge. How it is resistance is formed? කොහොමද formed? No, I know it is direction. I know it is opposite force. Yes. I ask how it is formed. It should have a reason. Yeah. For this electron movement, it is opposite force. Yes. Opposition force. I know this. Yes, that I explained. I ask from you how it is formed. What is the reason? Any idea? Quickly, we don't have time. Today we need to discuss all up to resistance systems. Then resistance, if we can discuss today resistance systems, next week we can complete the lesson. Yes, due to barriers. The barriers are what? What are the barriers? What are the barriers? Okay, if you go to previous I given figures, you can understand how it is forming resistance. Previous I given the electric current flowing there. They are the reasons. If we consider about conductor, it not only contain free electrons. Free electron only one type of carriers. They are only one, but it has another ions as well. Another ion, positive ion, different neutral ions. It has a lot of ions. Therefore, what sounds? Yes, that is the method. That's the reason. It has a lot of other atoms. No? They are collide with nearest atoms when it is flowing. That's why there is opposition force for this motion, electron motion, that we called as. Then what happened? The electron motion speed is decreasing. Then the current flowing also decreasing. Current flowing also decreasing. That is a resistance. If it is collisions are increasing, these electron collisions increasing. That's why in conductor, I told Amar, conductor like copper, like good conductor, when temperature increasing, it conductivity decreasing. Remember, I told the reason is, what is the reason? The resistance increasing. There are collisions increasing. Collisions when increase of collisions, they are the barriers increasing. When barriers increase, resistance increasing, then conductivity abilities decreasing. Conductivity abilities decreasing. I got that is the resistance, the barrier, opposition force. Understood? Amar, I got? Sandeep, the resistance forming. Yasundu, I got?
Yes, sir.
Good. Okay, then we measure the resistance of any circuit or conductor by ohm meter. I have given the meter. There is another instrument that we call multimeter, that we can measure every measures resistance, current, and volt value, voltage, everything. That not given in this diode, only given small meters. Okay. Okay, now we come to very important factor, that also very important. Okay, today I'm going to cover up to resistance systems. Resistance systems. Then within next week lesson complete. In our next Monday we can discuss questions. That within this month every part of the electricity lesson will be completed, and we have only one. Then after today we have only 1.5 lessons only. Environment chemistry and calculation part of the electricity lesson. Okay, then 99.5 of syllabus completed. Now you have huge responsibility now. Go through again lessons and complete works from your side. Your responsibility. Complete everything again and again. Continue working now. You have very limited time. Continue working now. And I think I'm marking your yesterday exam. I think only some students completed well. Okay, done well, but I don't know. Still, I don't know. Physical students only online markings, online answer sheet I have. Okay, I'll let before next it I'll give you marks. Before next Monday I'll give you mark, and please update your MCQ marks. Otherwise, I can't finalize your mark. Update within today. Okay? You have Excel link in the group. Update your MCQ marks with your name and MCQ exam number 5 MCQ marks only I need. Then I will upload your essay part marks and total marks. I will update in the sheet. Then you have full result sheet. Then you can compare after all exams. Now you have, this is exam number 5. You have another 1, 2, 3, 4 exams. 4 exam. The final exam I hope to do as a physical exam. It's a home exam, but online student I will send you the full paper, printed paper. Then you can open the paper I given time and you can answer and scan and send me. I will let you know how to do it. Then you have another 4 exams. Okay, with this exam you have 5. Okay, altogether you have 10 exams. This is 5th one. You have another 4 exams. If you're doing well within this 10, that means you have another 4 is completed. The previous one, if you're doing well in these 5 exams, you can get a super result. In SFT, you can get A. If you can balance other subject with same as SFT, you can get all subject 3A pass very easy. If you work like this, actually it is not a magic. You can do. Okay, back to lesson. Okay, then the resistance is the opposition force or barrier to electric current that we call as a resistance. It is coming with collide with atoms and electron to electron collision. Electron to electron and atom collisions are the main reason for this. Collide mean get negative. Collide with this collision, their movement is slow down. That's the reason. Electron movement slowing. Okay, when we consider about resistance, there are 3 main factors affect. Very important, and that is very important. When we consider about resistance, there are 3 main factors affect. The first one is the resistance. Capital R. There are 3 main factors affecting. The first one is the length. Length of conductor. The second one is the cross-section area. The second one is the cross-section area. The third one is the matter type. Matter type. Length, cross-section area, cross-section area. The final one is the matter type or substance type. Matter type, its symbol, if you want, its symbol is rho. Matter type. Matter type. Okay. Now tell me, when increase the length of any conductor, when increase the length of any conductor, what have they are the factors? Remember, they are the main factors affect to the resistance of any conductor. Resistance of any conductor, length of the conductor, cross-section area of the conductor, and the matter type of the conductor. Okay, now tell me, when increase the length of any conductor, length වැඩි වෙද්දී, when increase the length, what happened to the resistance? Increasing or decreasing? When increase the length, increasing or decreasing? What do you think? Quickly. Think I have, oh, sorry. This is a one conductor. This is another conductor. Think it is length increasing. Length increasing. What happened to the resistance? Am I wrong? It's wrong. Yes, resistance increasing. Why? Why? Think that's a same copper rod, copper resistance, copper conductor. It is 1 meter length. It is 1 meter. It is 2 meter. 2 meter. If it is resistance 10 ohm, this one resistance 10 ohm, this one 20 ohm. It's double. When understand the reason, when increase the distance or when increase the current flowing length or distance, it's the barrier is increasing actually. With barrier, its moving distance is increasing. With that, resistance increasing. When increase the length, the resistance is increasing. Resistance is increasing. Okay, now you need to remember, with increase the length, resistance is increasing. Resistance එක වැඩි වෙනවා. Now, if we think a cross-section area, cross-section area, I mean think okay, same length, 1 meter, 1 meter. Cross-section area 1 square centimeter, 5 square centimeter. 5 square centimeter. Okay, increasing or decreasing? When increase the cross-section area, same material, copper and copper. when increase the cross section area, good. Isuru, when increase the cross section area, what happened to the resistance? Increasing or decreasing? That's a think with reasons. How the resistance is forming, everything you have to think. Very good. When increasing the cross section area, Amar, when increase the cross section area, the resistance is decreasing. Why? The barrier is decreased. They have more space to flow electrons. That's the reason. Understand with reason. When increase the cross section area, with the barrier is decreasing, we have the electron has more space to flow. Therefore, when increase the cross section area, it is decreasing. Then finally we can decide, finally L increasing, the R and L has direct proportional relationship, directly proportional relationship, no? R, L increasing, R increasing, length increasing, R increasing. You have to remember R and A, it has inverse proportional relationship, no? When A increasing, R decreasing. Understood? Adisha? They are very, very important things you need to remember. Always, if you not remember basic part we discussed up to now, after Ohm's law, you need to remember very well. No, temperature is the external factor, Amar. Temperature, it is external factor. They are internal factor. Length, cross section area, matter type. The temperature, due to temperature also it is changing, correct? But that is the external factor. We can, without, you know, in sometimes some instruments only working in air condition, only some computers, high performance computers, we can't keep in normal temperature. We need to always keep in AC room with favorable some specific temperature. If it is 18 to 21, like that is external factor that we can change. They are internal factors. Matter type, cross section area, length, they are the main factor affect on resistance. Not only temperature, other physical characteristic, physically available, relative humidity, pressure, they also affect on the resistance. They are external factors. Understood? Okay, now this is the relationship. According to that, the R directly proportional to the L over R, sorry, L over A. Correct. Yes. L over A. I multiplied L into 1 over A. If you can't remember this one, you can think like this. L into 1 over A. L into 1 over A. Now I am going to say same as previous. I am going to remove this proportional mark. I am going to remove this proportional mark. If I remove this proportional mark, then same, a constant need to come, that is a rho L over A. This is the equation for the resistance. This is the equation R equal rho L over A. R equal rho L over A. Rho is the factor that is dependent on the matter type. Rho is the factor dependent on the matter type. The rho we called as the rho. That's a Greek letter that we use for density. Hydraulic density also we use the rho. I think you can remember. Hydraulic density. Yes. For hydraulic density also we use this rho. R equal rho L over A is the resistance equation. Resistance equation. Okay, how we remember this? There are three main factors affect on the resistance: length, cross-section area, and the matter type. Length increasing, cross-section area, so length increasing, resistance increasing, directly proportional. Cross-section increasing, resistance decreasing, inversely proportional. According to that, we can get a relationship R equal rho L over A. Any doubt? Please ask. Okay, if you want, you can make a small short note. Important point. That's important point. Okay, in doubt? Understood? Okay, that is the factor depend on the matter type. Okay, rho. Do you know what's the rho? Name of the rho? Do you know what's the name of the rho? Name. Amar? Do you know what's the name of the rho? That's a constant depend on the matter type. What's the name? Very good. Resistivity. Resistivity. Name the rho is the resistivity of the conductor. That is a constant depend on the material type. Resistivity of the conductor. Resistivity of the conductor. Resistivity of the conductor. Resistivity of the conductor. Okay, I'm going to erase. I'm going to erase. Okay, I have given there are three main factors, internal factors. We're not considering external factors, length, cross-section area, and the conductor type of resistance, that means material type. When the increased length and resistivity, that means material type, the conductor, the resistance is increasing. That I have given little complex way. Okay, that's I in the green board I given the simple way. Okay, this one given in little complex way. The same thing as the cross sectional area of conductor increase, resistance decrease. That given same. Okay, now you can see this is the flowing conductor. Okay, R directly proportional to the L, R indirectly proportional to the 1 over A area, then R equal rho L over A. R equal rho L over A. This rho is the resistivity. Resistivity. Remember, resistivity of the conductor. That's a factor depend on the material type. The resistivity is a factor depend on the material type. Okay, others are internal factors. L, length, area, the resistance, they are material internal factors. Okay, this should be not P. Okay, it is rho, but in it is typing, it is coming P. It is rho. 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 Resistivity. Resistivity. Okay, how many parts we need to complete today? We can start this with this experiment next day. Okay, if we complete up to this page, that enough. Okay, resistivity. Oh, now 54. I have, okay, within short, oh, 54 now. Okay, let's see. I have another meeting at 10. Okay, quickly complete this. Then the resistivity, the R equal rho L over A, this is the equation. Then the rho is the, understand these factors, okay? The R resistance, rho is the resistivity, L is the length of the conductor, A is the cross-section area of the conductor. Then R equal rho L over A, very simple equation. Then what is if I isolate the rho? If I isolate the rho, then what is coming? R A over L, no? If I isolate the rho, then what is the unit of this rho? Can you calculate the unit of the rho? Electric resistivity. Electric resistivity unit. Electric resistivity unit. Can you get? Electric resistivity length. electric resistivity unit, not the length, unit. You can see the R unit is ohm. R unit is ohm. R unit is ohm. It is a square meter. Yeah, what is the unit? I need your answer. What is the unit of rho? What's the unit of electric resistivity? Very good. Ohm meter. Then divide by meter. Meter to 1 meter cancel out. Then ohm meter is the standard unit of the ohm meter is the standard unit of the electric resistivity. Not Amar, not ohm per meter. Ohm per meter mean ohm minus 1 meter. Ohm meter minus 1. See, meter to meter cancel out. Then ohm meter is correct, right? Understood? Yes, ohm meter is the unit. Ohm per meter mean ohm divide meter. No, ohm meter is the standard unit. Okay, I have given the definition. The resistance between two ends of a conductor, unit length and uniform cross-section area, a given temperature is called as a electric resistivity. Okay, that's the small definition for the electric resistivity. Rho equal. Okay, actually these definitions you don't need to remember. Okay, you can make relationship like this. Think rho equal RA over L. RA over L. Then think it is divide by L. That's mean unit length. The resistance of unit length with uniform velocity. See the resistance between two ends of the conductor, unit length, uniform cross section, that we called as a electric resistivity. Okay, that you can remember from the equations. Only equations you can make a definition and keep remember. Okay, now that is the resistivity. That's the resistivity rho. That's another, that's called as conductivity. Electric conductivity. The conductivity is the, the conductivity and resistivity has inverse proportional relationship. When increase the resistivity, the conductivity is decreasing. When decrease the resistivity, the conductivity is increasing. That is a relationship, inverse relationship. Therefore, the rho, not rho, but we symbol, I can't remember the name. The symbol name? Let me remember and tell you. Okay, this is the, what's the name? Sigma, yes. Yes. Sigma equal the reciprocation, that means opposite, 1 over rho. The conductivity equal 1 over rho. That's mean when increase the opposite. When increase the resistivity, conductivity increasing. When increase the resistivity, conductivity decrease. When decrease the resistivity, conductivity decrease. You can see in increase it is decrease. That's a relationship. Okay, that's the final thing today we need to discuss. The reciprocation of the electric resistance 1 over R we called as a conductness. conductance. They are not usually using. That is, keep in mind the S is the conductance. Conductance equal 1 over R. Conductance 1 over R, and the conductivity unit is conductivity standard unit ohm meter. Then the conductivity sigma conductivity standard unit is ohm minus 1 meter minus 1. Ohm minus 1 meter minus 1. The conductance standard unit is S. Standard unit is per ohm. Per ohm. Okay, they don't need to remember, only you need to keep in mind this equation and these definitions for general idea. Okay. Okay, if you have any doubt from today's lesson, 50% of electricity is completed. I hope to discuss next week resistance, continuous advanced part, and Kirchhoff law. Okay, then the electricity is completed. You can again please today or tomorrow again go through this tute. Again go through this tute and your short note and everything refresh again. They are otherwise you again don't need to do anything for the electricity. Electricity is very simple. Okay, this is I think that's I think it is student again doing this same session in the engineering technology also. BST student, I think they only doing electronic part, I think. Correct? In BST only you have electronics, no electricity. Only you have only basic parts there. Yes, only we discussed previous electric current flowing, these things, no? Yes. Automation focused. Okay, but this lesson we not going to discuss electrics, only electricity only we doing. Electronics you doing in the ET, I think. Okay, okay, that's the today lesson. Next week we starting from the resistance advanced part. Then we can continue up to end of the lesson. Now we have another very small part. 50% is completed. Now you have only 1.5 lessons remain. That we can within this month we can complete this electricity everything, and next month we only remain environment chemistry. Environment chemistry you all have tutes. Please go through this, and it's only given, it don't have any space. You full note you have, you can go through, and if you want you can complete within, if you want to complete within this month you can go through and complete, and before 2 months you can complete everything in the syllabus and you can ready for the exam. Okay, that's all for today. Any doubt, please ask quickly. Okay, good night, goodbye. Tomorrow you have practical 9 AM.